everyone, we're going to work on combining operations on radicals. So we will have problems with addition and subtraction as well as multiplication. We'll also work on combining addition and subtraction with division, but we're going to save that one for just a little bit. We'll work on that in a very specific way. We'll have specific goals. Okay, so first problem, root 6 times 2 root 15 plus 5. This is really just a distribute problem. Maybe you'll notice as you work through here that a lot of what we do with radicals looks a lot like what we did when we were learning operations on polynomials. So here, I just need to distribute my root 6 through, and I will get 2 root 15 times root 6 plus 5 times root 6. And that's the distribute step. I can do a little better to simplify. So you should always be trying to simplify these. For starters, I have a property that allows me to split up or break apart roots. I know that root A times root B is always the same as root A times B. So I'm going to use that in this case to combine the two roots. And I get 15 times 6, which is root 90. Plus 5 root 6. The radical parts don't match up, so I haven't gotten very far with this. But I think I'll see if I can make them match up. And in fact, I would say that I went ahead and multiplied the 15 by 6, but there's something to be said for just keeping it split up a little bit more. So we have 15 times 6 that we know we're starting with, so you could have just written that instead of figuring out the 90 if you know you're going to go a little further. 15 is 3 times 5, and 6 is 3 times 2. So I do get a pair of 3's that I should be able to subtract out. 6 is 2 times 3, so I'm not going to be able to simplify that second radical at all. So I mushed it together just to take it back apart. I did get a factor of 3 out of each of the original radicals, so I can separate out both of those 3's now. I'm left with a 5 times 2, which is just going to be a root 10. Okay, almost done. I can make that 2 times 3, which is 6 root 10 plus 5 root 6. And those are still not radical parts, but you should simplify regardless to make sure and to practice your simplification. So that will be my final answer. If I had managed to get 2 root 6's out of that, both of them having a root 6 or both having a root 10, I would continue. As it is, I can't extract any more roots. Do check if you're not confident that you've broken it down all the way. But 10 doesn't break up into anything other than 2 and 5, and 6 doesn't break up into anything other than 2 and 3. Okay. Next problem is just adding a little bit of mess to this. I now have addition in one set of parentheses and subtraction in the other. This is basically a FOIL problem. So you can look at it as like a double distribute, which is where FOIL really comes from. So I have 3 times 3 minus 2 root 7 plus 2 root 7 times 3 minus 2 root 7. This is basically the reverse of the factoring trick we use if you're getting stuck with guess and check. So we block this all up. Think about it as a single thing that we distribute and multiply by the 3, and then distribute and multiply by the 2 root 7. And then if you're doing it this way, you will have to distribute again. So we will get a 9 minus 6 root 7 plus a 6 root 7, and then what's this one? Negative 4, I can multiply the 2's together, and then root 7 times root 7 is just 7. It's a root 7 squared. I think I'll even write that because we have to rewrite everything once more anyway. So that will just leave me with a 7. Square roots and squares will cancel as long as they happen right back to back in your order of operations, as long as there's no plus under the root or something along those lines. Okay, so something really nice is happening here. The plus 6 root 7 minus 6 root 7, that actually adds up to 0. So even though those were kind of messy, they drop out in the end, and I get 9 minus 4 times 7, which is 28, otherwise known as negative 19. So this is my final answer, but I want to talk about a couple of things. One is it would have been okay to use FOIL. If you do that when you're multiplying out polynomials and you'd like to use it here, it will work for you. root 7. So our first 2 is a 3 times 3, which is 9. Our outer 2 is a 3 times 2 root 7, which becomes 6 root 7. Our inside is a negative 2 root 7 times 3, so that becomes negative 6 root 7. This should start looking familiar. And then our last 2 is negative 2 root 7 times positive 2 root 7, which becomes a negative 4 when you multiply the negative 2 times 2. And then another root 7 times root 7, which becomes root 49 or 7, however you want to look at that. And that will get me that exact same answer, so I won't walk through all the steps, but I'll say that should get you the negative 19 as well. So exactly the same answer. It's just a shortcut. FOIL is just a shortcut. So if you want to really understand what's happening in between, you can write it out the slightly longer way. If you feel comfortable with that and you want to do a little bit less writing, you can use FOIL as a shortcut and it will get you there. The other thing that I want to make a big deal about here is the fact that we multiplied two messy radical things together and we got an integer. There's no roots left in my answer. This is really powerful. We use it in a lot of situations where we're trying to eliminate radicals. It's kind of amazing. So what I want you to remember here is that if you have a binomial, so that's two terms added together, a plus b, or it could be subtracted, and you change the sign in the middle to a minus root b, again, or vice versa, it doesn't matter which one you start with, these are called conjugates. And again, they are useful in other situations besides just clearing out radicals. That's one way. Imaginary numbers is another place they're really useful. They're pretty handy. So two binomials with the opposite sign in the middle are conjugates. And you can even get a little bit broader than that, but that will serve our purposes. So if you have a 2 plus root 6, 2 minus root 6 will be its conjugate. If you have a 2 root x minus 1, 2 root x plus 1 will be its conjugate. If you have a root 3 plus root 7, root 3 minus root 7 will be its conjugate. So it doesn't really matter what the two terms are. We're looking at a lot of radicals, but they don't even have to be radicals. And one of the things that makes conjugates so powerful is, we'll just say note, a plus b times a minus b. This is related back to our difference of squares. When you multiply it out, you'll get a squared minus ab plus ab minus b squared, which is a squared minus b squared. So if you multiply conjugates, you get a difference of squares, which is why they eliminate radicals, because if you end up with something squared minus something squared, any roots that you started with will be gone. This is going to be a much bigger deal for rationalizing denominators or numerators, which we'll do shortly, but for right now, just recognize it, start getting used to the vocab. You'll just have a little bit of this come up. Okay, let's go ahead and continue with our multiplication. We have a 3 minus root x times 2 root x plus 5. And I'm going to go ahead with the FOIL method because I see a lot of students use that. But again, you could absolutely look at this as I'm going to take the 3 minus root x and make sure it gets multiplied by the 2 root x and by the 5. That's what FOIL is doing for you. So if we go straight to it, what did I just erase? That was an 8. There we go. We'll get the first two. 3 times 2 root x is a 6 root x. The outer 2 is 3 times 5, which is a plus 15. The inner 2 is a negative root x times a positive 2 root x. So we will get a negative 2, and then root x times root x is the same as root x squared, which again will just be an x. If you have the possibility of some negative values, there's a little twist on that, but we'll go with just an x for now. And then our last 2 is a negative root x times 5, so we'll just write that 5 out in front so it looks a little prettier. And then we do want to check and see if we got any like terms. I think I did again. I got a 6 root x and a minus 5 root x. So when I combine, that will be a lonely old root x plus 15 minus 2x. And that looks pretty good. I think I'm set. Okay, just one more of these. And again, make sure you check and see, is there anything I can extract out of roots as a last step? You won't see a ton of that with the multiplying, but I think you will see some of it. So last but not least, root x minus 3 root 2 squared. So here I just want to give you that big reminder that squaring something means multiplying it by itself. Exponents do not distribute, so you cannot split that up and say root x squared minus 3 root 2 squared. You'll get part of the answer, but not all of it. So I'm just going to write that out the long way and go back to my foiling. So a root x times a root x is just a plain old x. It's a root x squared, so the square root and the square will cancel. My outer 2 is a negative 3 root 2 times root x. I'm going to write that, but you can go ahead and combine now if you would like to. I just want to make a big deal about this once more. My inner is another negative 3 root 2 times root x. And then my last two are negative 3 root 2 times negative 3 root 2. So that becomes a positive 9. And then root 2 times root 2 is root 4, which is just 2. So when you multiply a root by itself, it does cancel, but you have to be very careful when addition and subtraction are in the mix. Okay, so I see an x minus 3. Here's what I wanted to make a big deal about again. What we're doing when we multiply a root by itself is using that property that says that's the same as multiplying and then taking the square root. So kind of just writing an extra step here, but I just want to make sure everyone's seeing what's happening there. And then very last thing, I can combine the root 2 x's. So I have an x. If I have negative 3 of those root 2 x's and I subtract another 3 of those root 2 x's, I'll get negative 6 of them. And then plus 18. And I don't have anything that I can extract to simplify. I don't have any more like terms, so I think I'm all set. Thanks for watching.